Welcome. In this video we are talking numbering systems. We're going to be looking at two main numbering systems: decimal, base 10, and binary, base 2. So decimal are numbers represented between 0 and 9, noted as decimal or dec. That's the numbering system we're most familiar with. The nice thing with decimal is it can represent all numbers. 1, 0, 2, 5, 20, 30, a million, it doesn't matter. All numbers can be represented as decimal numbers. Binary numbers can also represent all other numbers. Binary uses just the numbers 1 and 0. So if we're talking binary, there's never a 2 or 4 or a 5. Binary is just ones and zeros. It is important to understand that the number 1 in binary doesn't always equal the number 1 in decimal. So we have to talk about what numbering system we are using. So things like the number 1 can, in this example, actually equal 1, because we only have 1 in the 1 position. For the decimal number 2, we have 1 in the 2 position. So let's look at converting a binary number to a decimal number. Everything is being built off of a chart of 8 bits. So you'll notice the chart going 1, 2, 4, 8, 16, 32, 64, 128. That's a pretty common chart because we're dealing with groups of 8 bits because we're dealing with networking. So if we're converting the binary number 1010 and we want to convert that to decimal, what we do is we line up the numbers. So here we line up the 0 to the 1 spot, the 1 to the 2 spot, the 0 to the 4 spot, and the last one to the 8 spot. We add where the 1s are. So 1010 in binary equals 10 in decimal. But if we're looking at converting a larger number, for example, we want to convert a 9-digit number and we only have room for 8s. How do we do that? What we do is we actually have the ability to add another space. You'll notice 1, 2, 4, they just are doubling. So if we look at 128 and we double it, that's 256. And if we have to have a 10th number, we just keep doubling it. But why is that? That's because in reality, this first position is the 0 position, so 2 to the power is 0. The next one is the first position, second, third, fourth, and so forth. 2 to the 7th, 2 to the 8th, and so forth. So if we have to add an additional bit, we just, if we're looking at this column right here, we can just keep doubling it. So the next one would be 512, or 2 to the power of 9. Again, since we started with 0, this is actually our 10th position. If we have to go to the 11th position, it should be 1024, and so forth. So we need to learn some language. If we are talking networking, we need to know at least 3 basic terms when we're talking our conversions. Bits. Bits are the smallest number that can be represented. In binary, bits are the 1s and 0s. And in reality, bits are what we're sending down a medium. it is going to be the electrical signals, on, off, things of that nature. Bytes are actually groups of 8 bits. Octets are groupings of 8 bits. So if we are dealing with 4, 5, 6, 7, 8. So here we have 4 groups of 8 bits. We can call that the first octet, the third octet, the fourth octet, and the fifth octet. That way we can disseminate which group of 8 bits we are talking about. So those are the 3 main terms we need to remember. So how many different numbers are there if we know how many bits there are? So if we know that we are dealing with 2 bits, we're dealing in the second position, because 2 bits are dealing in the second position. 2 to the power of 2 is 4. And that could be 0, 1, 2, 3. That's 4 different numbers. If we know we're dealing with 3 bits, 2 to the power of 3, that's a weird looking 3. 2 to the power of 3 is 8 numbers, 0 through 7. If we know we're dealing with 4 bits, 2 to the power of 4 is 16 bits, and so forth. So how do we do conversion? Now, how do we go from a decimal to a binary? We've already figured out how to go from binary to decimal, but how do we go from decimal to binary? Again, we look at our chart, 1 through 128. We have a random number given to us, 185. And what we do is, looking at this chart, we ask the question. Starting from the far left, can this number be subtracted from the number we're trying to convert, 185? Can 128 be subtracted from 185? Yes, it can. So, we put a 1 there. Yes, it can. 185 minus 128 is 57. Can 64, the next number, be subtracted from 57? No, it can't. So you'll notice there's a 0 there. We can finish out the math. So I'm just going to do it longhand. 185 minus 128, 57. 64 can't go into it. 32 can. So if we look at 57 minus 32, that's 25. Can 16 go into 25? Sure can. That's why there's a 1. That leaves 9. Can 8 go into 9? Yes, it can. That leaves 1. Can 4 go into 1? No. Can 2 be subtracted by 1? No. Can 1 be subtracted by 1? Yes, it can. And it is 0. So that's how we get the binary number 10111001. That equals 185. This is binary. I don't know why my pen is skipping so much this morning. Binary. And this is decimal. The sad part is you don't get to get away from this. Subnetting is a huge portion of networking, and subnetting is built off of our binary system. So if you have any questions or concerns, please reach out. Thank you.